Okay, now we're going to talk about compressions and stretches. And compressions and stretches are a little bit confusing, so we really want to pay attention to them so that we can see what's going on. Okay, the way that we'll talk about vertical stretches and compressions is if we see a number that is being multiplied to the outside of a function. So, and when this happens, of course, in order to get the y value, the new y value, we'd basically multiply the old one by a. We'll do an example of this so you can see what goes on. The definition here says that if the a value, or whatever this number is here in front of the original function, if it's greater than 1, it stretches vertically, the original function. If this number a is between 0 and 1, it's going to compress vertically the original function. Okay, the best way to look at this is to look at an example. So let's take our graph here. I've graphed the square function, f of x equals x squared, so it looks like this. And remember, we found these points by taking some x values and squaring them. So 1 squared is 1, 2 squared is 4, just basically plugging it into the equation. All right. Now what I want to do is I want to multiply something on the outside of the function, in front of the function. I'm going to first of all do an a value bigger than 1. So let's say 2. What if I were to graph the function 2x squared? And let's see what would happen. Well, if we used an x value of 0, that would be 0 squared is 0 times 2 is still 0. What if we use an x value of 1? 1 squared is 1 times 2 is 2. So now we'd be at this point, the point 1 comma 2. What if we used an x value of 2? Well, 2 squared would be 4. That's where we normally were. Times 2 is 8. So the point 2, 8 is on this graph. Now, because of symmetry, I'm going to fill in these other points very quickly. But this is the graph, and again, I know my drawing skills are not the best. This is the graph of 2x squared. Okay, now, what if I'm talking about an a value that is between 0 and 1? Something fractional. Let's look at 1/2 x squared and see what that looks like. Okay, so if I take an x value of 0, squared would be 0, half of that is still 0. What if I took an x value of 1? 1 squared is 1, half of that is now 1/2. And because of symmetry, we're going to have that on the other side also. What if I did an x value of 2? 2 squared is 4, half of that is 2. So we'd be at the point 2, 2. So can you see what's going to happen here? What if I did an x value of 4? 4 squared would be 16. Half of that would be 8. So that would be right there. And we'd have another one over here. Can you see that it is taking that graph and it is making it wider, basically? It's very interesting. Now, back up here where we talked about this, we said we have a vertical stretch if the a value is bigger than 1. Okay, so this was our red graph here with an a value bigger than 1. Can you see that each one of these points has been stretched up from where it used to be? That's a vertical stretch. Now also, you see that it said we had a compression vertically if a was between 0 and 1. Okay, so now we're talking about this blue curve. Can you see that we compressed it or we pushed it away vertically? Each one of those points? Very interesting.